Hi friends, I had a request to explain rejecting or accepting your null hypothesis. So I'm going to go back to the individual data for the chi-square that I gave you that was based on Katie's data for the peanut butter M&Ms. You'll have to do the same thing for both your individual set of data, like right here, in this section. And then also once everybody posts on that document for the class data, you'll do the second chi-square analysis for those data also. So let me walk you through real quickly what I did here. Katie's data, her raw data, her counts for what she observed were this first line here. I know it's kind of hard to read because I had to write with my finger, but we're making do, right? All right, so these are the numbers for each of the colors. The expected, that was the, can I scroll up here? Yes, I can still. Good. So the expected is this right here for the peanut butter. I just took her total number, which was 190. So out of that 190, I went back up here and I applied these percentages to that 190. And that's where I got my expected numbers of 19, 38, 38, 38, 19, and 38. All right. So it was like a 10% of the 190, 20% of the 190, 20% of the 190, 20% of the 190, 10%, and 20%. Okay. So now my difference, I just subtract them, and you're going to probably have some negative numbers, which is fine. So you subtract the expected from the observed. So O minus E, 33 minus 19 equals 14. 40 minus 38 is 2, 26 minus 38 is negative 12, and so on. You go ahead and square this number right here, the difference squared. So 14 squared is 196, etc., 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 etc. Okay? So now this 1, 2, 3, 4, 5th row right here, this is where I had to write it up here because I needed some decimal points, so I needed some more room, right? So I wrote these numbers up here. So my observed minus my expected squared divided by my expected, using this number divided by my expected, I got 10.32 for the brown. I got 0.11 for the blue. I got 3.79 for the orange, 0.11 for the green, 1.90 for the red, and 1.68 for the yellow. Now this final equation that we're using right here, this is the chi-square official total equation. It just means the sum. So sigma means sum. The sum of all of these all of these 6 numbers put together. So I added 10.32, 0.11, 3.79, 0.11, 1.90, and 1.68, and I got 17.91. Okay, so now I have to go down. The next thing I do is figure out my degrees of freedom. The degrees of freedom is always your number of total choices for your outcome minus 1. Don't know why, it just is what it is. So I had 6 possible outcomes, right? I had my number of blues, my number of browns, oranges, reds, yellows, and greens, right? So I had 6 choices. So my degrees of freedom is the 6 minus 1, which is 5. That's where I got degrees of freedom. You need both this number and this number to go down to the next part right here. Let me write on this 1 second. Erase this first. Go back up here. Okay, so now I'm going to write on this. Now I've got these 2 numbers. My 7.91, that was my number up here. I can't scroll up because I'm in drawing mode, but my 17.91 or whatever it was is my number from up there. My degrees of freedom is 5. I need both of those numbers. And I find my degrees of freedom first, which is right here. That's 5 degrees of freedom, right? So I know I'm going to be in this row right here. And then I find my 17.91. Well, guess what? It's not on there. Why? Because it's way over here, right? It's a really big number. The bigger the number, you can assume pretty much you're going to reject the null hypothesis. So, because see how it says it right here? Anything to the right of this line, you're going to reject it. Anything to the left, and you're going to accept it. So what does that even mean? My number was 17.9. Oops, 17. Come on, there we go. 0.91, I think, or thereabouts. And so I'm absolutely going to reject the null hypothesis. What does that mean? That means that the difference between what I observed and what I expected was too great to be due to random chance alone. So my null hypothesis, let's go back to that again for 1 second, which means I got to do this. Boom. All right, if I go back to my null hypothesis up here, it's always going to be the same. Right here, let me draw again. Boom, boom. Any difference between the observed and expected data due to random chance alone. That's my null hypothesis. That means there shouldn't be a big difference. But are we going to accept that or are we going to reject that? Let's go back down here to see. We said that we were going to go ahead and reject that. That means that the numbers are too high. The differences are too off. When I go up here, there's too big of a difference between the 33 that I observed and the 19 I should have seen, between the 26 and the 38. 40 and 38, that's pretty close enough, right? 36 and 38, close enough. 25 and 19, too big of a difference. 30 and 38, too big of a difference. And so this number of 17.91 tells us that what we observed was too far off from what we expected for it to be just a human error or a slight chance, right? There's something else going on there. Either the Mars company lied with their percentages, whatever, or there's something else going on. Could be a huge human error. Maybe Nick snuck into class and stole all but, I don't know, like 2 of the green M&Ms, and that's going to throw your numbers way off, right? Okay. Obviously, we got to pick on Nick because he's the only guy in the class, and we've only got a couple weeks left to pick on him. So that's the explanation for rejecting or accepting the null hypothesis. This chi-square number that you come up with right here, after you add all of these numbers right here, you have to apply it down here to this chart. And if it's to the right of this line, you reject the null. If it's to the left of the line, you accept it. If you got any more questions other than that, just give me a shout and we will talk about it more on Monday. But other than that, just give me an email. Have an awesome weekend. See you guys.